right, today our goal is I can determine the slope using a graph and points. Okay, so this two-part lesson, uh, after you do the first part, if it appears fairly easy for you, please try to do the next video. All right, so let's talk about what slope means. Now, we could brainstorm and we could come up with some different words, and that's what I've done here. I've come up with some different words. So let's take a look at the word pitch first of all. When I talk about pitch, usually that's in construction, and we're talking about how steep something is. Okay, now you can see here in this diagram, they're talking about something rising and running. Sorry about that, but rising and running. And we call it the pitch or slope of a roof. And so when you're driving around, you'll happen to notice that some roofs are steeper and some are flatter than others, okay? And so that is one place where we see slope, because slope and pitch mean the same thing. Now, if we go back and we look at another one, if we look at grade, and we're not talking about their grade in school, grade, usually we use it when we're talking about movement. So if we're talking about driving along, and especially for trucks, it's very important for them to know how steep or the grade of a road, so they know that based on their weight of what they're carrying, as well as the size of their truck, that they know that they're going to be able to stop. Now, there are not a lot of hilly areas around here, but if you go further up north, or even if you go out west where there are mountains, this is important for truck drivers to know what they're coming up to. Okay, another place that you see it, this is called a transit, and they're talking about the grade. So if they want, in some cases, they want something to be very smooth, so they don't want to have a great slope. Or if even when it comes to road work, they sometimes want the grade to be towards the curb, so that's where the water runs. Okay, also if you notice another picture here, we talk about at the top a gentle grade, a fairly steep, and then very steep. But notice when they're talking about grade, they also have the word slope in there. So again, it's kind of interchangeable with slope and grade. Now if we go back and look at incline, okay, incline, often we talk about an inclined plane, and what we're talking about here is often has to do with work, also work as far as the amount of effort. Okay, so obviously the steeper the incline, the more force it's going to take us to move something, whether what we're moving is a wheelbarrow full of something, or whether we're pushing a ball, or it looks like a giant boulder up a hill. Okay, so in this case, when we talk about incline, often it has to do with physics, and we're talking about force and resistance that's going on. Okay, and the last one that I have here is actually the word slope. Now, where do we see slope? Well, we see slope when we're talking about skiing, sliding down something. Often you hear, watch going down a slippery slope. Same kind of thing. It's talking about how steep something is. Okay? So that is just a little quick rundown of what slope is. Now, mathematically, what we're talking about slope is really, it can be considered a unit rate. Now, we've done unit rate from our first unit. Remember when we said, 8 pencils per dollar? So that was unit rate. So the same thing happens when we're talking about slope as far as unit rate goes. So for instance, how much something will change per unit. That was the definition of unit rate. So now the something in this case is going to be the y value. Okay, so we're considering about the y value, and the unit is our x value. Okay, so the something and our unit is the x value. So we're comparing y's with x's. So if we go and look at a Cartesian plane, so we have our x's of x and y, and what we're concerned about has to do with the slope. So we're concerned about the change between the y's with the x's. Now, when we have a straight line, I can compare the y's with the x's at 2 points. So I could actually compare those 2 points. I could move it down here. If you notice that with the straight line, it doesn't matter where I start comparing it because those 2 points are always on the graph, whether I'm doing it down to the left or whether I'm going up further to the right. So what we're comparing here is what we call the change in y, and often we use this little symbol, this triangle symbol, which stands for delta. It's pronounced delta y. Okay, that's delta is actually a Greek letter. Okay, so delta y, so a change in y with the change in the x, or delta x. Okay, so the way that we write unit rate is a couple different ways we can do it, and we'll be interchanging them. Unit rate equals slope. It equals the change in y divided by the change in x. And it can be written also with the Greek letter delta, so the delta y divided by delta x. Now, what we're going to be doing here is we're going to be determining the slope of these lines on this page. Now, what we need to do here is we need to find a place where the line intersects the grid perfectly. Okay, so for instance, I'll pick one that you can see a little bit better. For instance, if I look at right here, the grid intersects here. Well, the grid intersects, but if you notice the line doesn't intersect at that location, we'll wait till it disappears. You can see that it doesn't cross it perfectly. Where did our pen go? Okay, you can see that there's this little spot here. So this line, the straight line, is not intersecting the grid exactly in the corner. So we want to find locations where it crosses exactly, because we don't know when it's halfway, whether it really is halfway or if it's 1/6 of a way, or sorry, 0.6 of a way. So I'm looking at this point here. I can see that it crosses there exactly. And then I go to try to find another place where it intersects exactly. Now, there are a few different places, but there's another location there. So the way we do this is we're concerned about the change in the y with the change in the x. Okay, so if you notice, I created a 90-degree triangle. Okay, so that I can actually count the squares. So the change in y here is 1, 2, 3, 4, 5. And my change with my x is 1, 2, 3, 4, 5, 6, 7, 8. So, sorry, that's my change of my x. So my delta x is 8. So when I'm talking about the slope, remember the slope equals the change in y divided by the change in x. So in this case, it would be 5/8. And we would leave it in lowest terms as a fraction. Okay, because that's going to be more useful to us later on. So let's try the next one. Now, what's different about this line is it looks different because it's going in a different direction. Now, if you notice the first one, if I read it, and we read graphs the same way we read books, we always read from left to right. So if I move my screen across, you can see what's happening to this line here is it is going up. So this means that it's positive. So moving up is positive. Compare it to our second example, and you can see as the line is appearing, which it is appearing right here, what's happening to the line? Well, it's going down, so therefore it has a negative slope. But the same thing applies. We need to find two locations where it intersects exactly, and it appears to be one here, and I'm just moving along trying to find another one which is really good. I'm thinking there for mine. Yours might look a little bit different, but mine's blown up because I'm doing on the smartboard. So here is my right triangle. So what's happening here is I'm falling down one. So I'm going -1 down, and I'm going 1, 2, 3, 4, 5 across. So my delta x is 5, and my delta y is -1. So my slope, and each time I do write the formula down, delta y over delta x is -1 over 5. And let's keep on going. We have a few more here to do. Again, the same thing. Is this a positive slope or a negative slope? Well, I can see that as I'm going across, the line is going up, so therefore it's positive. So it's a matter, again, of coming up with places where it intersects exactly. So it appears there's one point there. It appears there's another point here. And now I'm going to create my right-angled triangle. Now that I have that triangle made, notice what happens if I actually move it. If you notice, it moves, it should move exactly down the line. Okay, so I might be off just a tiny bit. I think my green ones on this here is just a little bit too long. So I'm going to just do it again so that you have an even better idea. So there it is till here, and then straight down. Yes, I know that's not a very straight line, but just to demonstrate. So I could have chosen a point there to there, but if you notice, I can't read what the location of those points are. They're not full squares on the grid. So that's why we've chosen these 2 points, because we can see that it intersects exactly. So we're going to go back to here, and we're going to count our delta x's and delta y's. So our delta y here, and we'll do it in green. We're looking at 1, 2, 3, 4, 5, 6, 7, 8. And our x's, we're looking at 5 and another 5, so we're looking at 10 for our delta x. And what we do, again, our slope is delta y over delta x. So we end up with that being 8 over 10. Now, this isn't in lowest terms because 2 goes into both 8 and 10, so that's going to then equal 4/5. And the next one, well, might have to look a bit close on this one. This one you can see is a vertical line. So how do I find 2 points? Well, I really can't. But if we look at what we're talking about here, delta y, and we look at delta x, well, the change in y, well, y keeps on going for kind of ever. Or if I actually chose a point, if I chose this point here, and say we're going to here, what's happening? Well, it could be the number 1. The point from that point to that point is 1. But what about our delta x? How far are we moving left and right? Well, I'm not moving. So that means that number is 0. Okay? And so let's, again, go and do that. So that's 0. So we know our slope is, again, delta y over delta x, which is going to equal 1 over 0. Now, I have a problem with that because in mathematics, we can't divide by 0. So when I have a line like this, my slope is undefined. So the answer is undefined. Okay, it's not 0 or anything like that. Okay, so I'm going to stop the video and we're going to do these last 2 questions together.